Alright, welcome back everybody. In this video we're going to look at some examples based on using L'Hopital's rule with the indeterminate forms of infinity over infinity, infinity times zero, and infinity minus infinity, and how we can deal with some of these situations. First we look at the form infinity over infinity here in example 1. If we look at this limit as x approaches infinity, we get an infinite amount over an infinite amount when we try to evaluate this via quote-unquote substitution. So we can apply L'Hopital's rule, and so we'll take the derivative of both the numerator and the denominator, and that's going to be 1 minus 4x over 6x plus 5. And if we evaluate that, we again get something infinite over something infinite. I guess technically it's negative infinity over negative infinity, or negative infinity over positive infinity. And then I'm going to apply L'Hopital's rule again. This turns into the limit as x goes to infinity of, I take the derivative of the numerator, the derivative of the denominator, and everything reduces out. And so the limit of that function is going to be negative 2/3. Alright, let's look at example 2. Again, we look at what's going on, and the natural log approaches infinity as x approaches infinity, and so does x. And so we're going to apply L'Hopital's rule. This turns into the limit as x goes to infinity of 1 over x over 1. Now this is something we haven't done up to this point, but when we do apply L'Hopital's rule, we can simplify this fraction as algebraically appropriate. So this is really equal to the limit as x goes to infinity of 1 over x. And as x gets really, really big, this is going to approach 0. Alright. Next we'll take the form infinity times 0, something like what we've got here. Find the limit as x goes to infinity of e to the negative x times the square root of x. And when I do that, e to the negative x approaches 0, and the square root of x approaches infinity. And we don't really know what 0 times infinity, or pardon me, something approaching 0 times something approaching infinity is always going to be equal to. So we're going to apply L'Hopital's rule to this, but first we're going to manipulate it a little bit algebraically. We need to turn it into something of the form either 0 over 0 or infinity over infinity. In this case, that's going to be easy. All I'm going to do is use the fact that I have a negative exponent to rewrite this as square root of x over e to the x. And now this is an infinity over infinity form. And so I'm going to apply L'Hopital's rule. Get the limit as x goes to infinity of 1 over 2 square root of x over e to the x. And just like we did in the last one, I'm going to simplify this. And that turns into the limit as x approaches infinity of 1 over 2 e to the x square root of x, which is going to be 1 over something that approaches infinity. 1 over something that approaches infinity is going to be 0. Alright, on to example 4. Here we've got the limit as x goes to infinity of x times the sine of 1 over x. And this is of the form infinity times 0, because x approaches infinity as x approaches infinity, and the sine of 1 over x approaches 0. So I'm going to manipulate this to turn it into something of the form either infinity over infinity or 0 over 0. I can't really do anything with the sine function, so I'm going to change this into the limit as x goes to infinity of sine of 1 over x. And multiplying by x is the same thing as dividing by 1 over x. And so this turns into, it's now a 0 over 0 form. So I'm going to apply L'Hopital's rule. And the numerator's derivative is negative 1 over x squared cosine of 1 over x. utilizing the chain rule. And the denominator's derivative is negative 1 over x squared. And so this turns into the limit as x goes to infinity of cosine of 1 over x. And as x goes to infinity, what's inside of the cosine function goes to 0. And as what's inside of the cosine function goes to 0, the value of that goes to 1. And so that is our limit. Alright, we're going to stop here for this video and come back and look at examples 5 and 6 in the next one. See you guys next time. Have a great rest of your day.